Hello everyone, welcome back to my channel Saisha Tech. This is Amok Kaliwa. If you are new to my channel, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. In the last video, we were understanding the concepts of odds ratio. What is odds ratio? Implementation of odds ratio in mathematical formulas of logistic regression, and we also understood about multi-class classification in logistic regression. In today's video, we will understand the practical application of logistic regression in R. We will initially start with loading a CSV file into R. Thereafter, choosing the best k-folds for k-fold cross-validation technique for bifurcating the train and test data. We will also utilize ROC curves. These ROC curves will help us to choose the best threshold for classifying the positive and the negative classes in logistic regression. Lastly, we will conclude with assessing the performance of the model using accuracy as the metric. This R code will help us to understand the logistic regression implementation. Let me walk you through these steps as we have understood them in the last practical implementation. I am loading the libraries in line number 12 and 13 which are required for building ROC curves. In line number 16, I am providing the file name which is the data set which we want to build our logistic regression. As we are using a four-fold k-fold technique, I am specifying the k-fold as 4. In line number 20, I am loading the data into R. Here we have 15 variables and 3209 observations. Let us understand the problem statement. We have an online gaming portal where they want to understand the churn and not churn of the customers using their transactional behavior pattern. In line number 34, you can observe the first 6 observations of all the columns. In line number 35, we are understanding the summary of all the variables. You can observe there are many categorical and some of the numeric attributes. Line number 36, you can observe the names of the data frame, wherein we have collected all the transaction behavior patterns of each of the customers. We have one attribute, that is the customer ID, but this attribute does not have any significance during model building. Hence, in line number 41, we are eliminating that attribute. Now you can observe we have eliminated those attributes. We are going to set the seed, because if we load this seed, the next time whenever we take the same data set, we can shuffle according to the same pattern. Line number 48 is helping us to shuffle the values of the data. Line number 51 is creating folds. As we have considered 4 folds, there are 4 folds created for each of the rows. I am creating 2 empty data frames for capturing the accuracies of train and test. As we have understood the k-fold cross-validation, wherein we take one fold as the test data and the other 3 folds as the train data. Here, for all the 4 folds, we are running a for loop and capturing those values. Let me run the for loop and understand the behavior patterns for the train and test, which is best using k-fold cross-validation. After running the for loop, now let us understand what is there in the for loop. Here you can observe from line number 62 to 64, we are considering one fold as a test set and creating the test data and the train data. We have set the seed so that on the same data, a same model is built every time we run the model. So after doing that, we have built the logistic regression model. Here GLM function is helping us to build a logistic regression model. As we have bimodal target attribute, we are considering family as binomial, formula churned versus all the attributes with train data. After building the model, we are predicting on the train data with 0.5 as the threshold for classifying churned and not churned. This confusion matrix is helping us to assess the performance for the train data set, and we are capturing that in our data frame. Similarly, we have taken the test data. On the test data, we have predicted and captured the accuracy. This way, we have assessed which observations should be considered for training the data set. Now, in line number 119 and 121, we are able to convert all the values to numeric for the test and train accuracy. From the different folds, accuracies of train and test, we are choosing the final fold. This final fold will help us to create the test rows. The final fold which we have chosen is fourth fold for bifurcation of the train and test data. In line number 30 to 34, we have chosen the test rows of fold K4 and created test data and train data. Only the train data and test data are utilized for further processing, hence we have removed all other files. With the train data and test data, we have built the logistic regression model and predicted on our test output. For K-fold validation technique, we have utilized 0.5 as a criteria for classifying churned and not churned. But that is not the best approach. The best approach would be considering the ROC curve, and with the ROC curve, choose the best threshold for classifying the target attribute. The line number 151 to line number 162 is helping us to build the ROC curve, choose the best value which defines the perfect cut. Let me run the function. Pass the values of predicted logistic regression output and the test actual data. With that, we have analyzed that 0.5165 is the best threshold for classifying the churned and not churned cases, wherein above 0.5165 is the churned cases and 0.5165 below are non-churned cases. With that information, we are classifying the predicted output of the test to assess the performance, building the confusion matrix, and assessing using accuracy as the parameter. Here you observe that we are achieving a 52% accuracy. This is how we can build a logistic model using GLM function, achieve a greater pattern using K-fold cross-validation technique for training the data, and bifurcating correctly using the best threshold of ROC curve. If you like my video, please like, share, comment and subscribe my channel and press the bell icon for the latest updates. Thank you.